Hello students, we're back with converting to radical form. So now we're going to go backwards and they're going to be given to us in exponential form and we're going to rewrite them with roots. So basically almost all of your problems are going to end up with a radical sign. Let's just figure out what stays inside the radical sign and what makes it out. So one thing you can do to kind of cheat a little bit is kind of start with a radical sign. Some things are going to stay inside of it and some things are going to make it out. So first of all, the only thing that has an exponent is the a value. This 12 is just a regular 12. So this 12 can just stay out of it. Literally, it can stay out of it. This 12 is not going to go inside the radical sign. It's just a regular 12, so leave it a regular 12. Leave it alone, okay? Now, the a is the only value that has an exponent. So this a, some of it's going to stay and some of it's going to move. Now, if you remember my analogy, the number on the bottom snuck in from the bottom to get into the radical sign. So the number on the bottom, the denominator, you always want to kick it out. All right, so if you're dividing by 3, kick this value out. Where does it go? It goes over here. So if you kick that 3 back out, the 2 is going to stay. And that's it. That's it. That's all you have to do. You're all done. So if I were to scroll back up to, right here. Okay, so you see how if I reverse this, this n is on the bottom, so I can kick that n back out, and that's where it lands. So you're just reversing what you did in problem 1, where the the root snuck in. Now you're kicking it right back out. That's all you're doing. All right, so the number that's on the bottom, the denominator, you kick it out, and then you write down whatever's left over. All right, so let's take a look at what's going on. That's your answer, by the way. You probably could sneak those values a little bit closer together. It's kind of tricky to put a number right next to a root. So, just do the best you can. So maybe you could probably sneak them a little bit closer together. But again, it's kind of awkward to put a root right next to a number. It's kind of weird looking, but that's the answer right there. Okay. So again, we left the 12 alone because it has no exponent. Anything that has an exponent is going to turn into a root eventually. Excuse me. All right. So this one's kind of goofy. I've changed this one a little bit from the book. This one's going to be a little bit nicer. What happens if you have a group to a radical exponent? Well, or a rational exponent, excuse me. Well, you just kind of follow your frying pan rules. So stick the 4/5 to everything, and let's do a quick rewrite. We're going to have 32 to the 4/5, and then we're going to have an a also to the 4/5. So just your frying pan rules. Now, 32 to the 4/5 actually turns into a number. If you were to evaluate it, 32 breaks down into 2 5 times, and if you pick 4 of them, it turns into 16. So 32 turns into a regular number. Sometimes it happens. Most of the time it does, sometimes it doesn't. So 32 to the 4/5 turns into a regular 16. Now a, since you're just a variable, some of you is going to stay inside the radical sign, and some of you is going to get kicked out. Again, the 5, divide by 5, kick it out, a to the 4, leave it in there. That's it. All done. Now, these look kind of weird because it looks like it's 16 to the 5th, but this 5, I'm going to try to stick it to the radical a little bit more here. That 5 should be more on the radical sign. There we go. That looks a little bit better. So now you can see why radical form is kind of goofy. It's a lot of really weird pieces and weird places. It's just kind of awkward to write. Okay. All right. So let's kind of rapid fire some here. 6. Kick it out. Okay, so it's going to be a root of 6, but then the 8 to the 5 is going to stay an 8 to the 5. That was kind of easy. Okay, so kick the 6 out and then rewrite it. The 5 does not have an exponent, so leave it as a regular 5. I kind of wrote this in too much of my space here, so we'll put the 5 right here, kick the 3 out, so we'd have a third root of x. You could write it as x to the 1, but you don't really need to. So we kick the 3 out, 5 stays a 5, so it's a regular number. Oh boy, this one. Oh man, I'm not excited about this, but here we go. So you can try the frying pan rules, or you can do this other method, which you just try to write it as a root, and then you see what reduces. So you can do the frying pan rules, or you can do this other method which I call root and reduce. Okay, so this one's going to be kind of ugly. You're only going to see like one of these, so don't worry about that. This is the only one you're going to see. Okay. So root and reduce. What do you mean root and reduce? Well, let's go ahead and kick the 3 out to start. So since this whole group is to the 2/3 power, you can kick this 3 out and rewrite it as a third root of 54 times y, all of that to the second power. Okay. Now the problem is this. 54 is not a root of 3. You cannot break it down. 32 you could break down into 5 parts because it's a fifth. There was an example up top where we could break it down, but anyway, you can't break 53 down into cubics because it's not a cube, okay? But what you can do, and this is kind of, it's one of those things where like you can do it, but it's like, why? 54 can be broken down into 27 times 2. And you still have the y right there. So you can break it down into this. Okay. Now, why is that important? Well, 27 is a cube. Okay, so 27 can be broken down. Okay. So if you break down 27 to the 2/3 power, this thing, actually, take it back. I'm going to rewrite it one more step just to make it look a little bit more pretty. So we have a third root of 27 squared. So basically now I'm doing here, I'm sticking this 2, I'm kind of following my frying pan rules inside the radicals. I know it's crazy, man. Just hang in there. Don't worry about it. Just hang in there. We're almost there. Okay. This right here, this can turn into an actual 9. Okay, because since 27 is a third root, you can break it down into 3 times 3 times 3, and then pick 2 of them. Okay, so you can break this down into 3 times 3 times 3, pick 2 of them, so that turns into a 9. So I'm going to rewrite this whole thing right up here. So that whole thing turns into a 9, and that's the only thing that can get out of the radical sign. This 2 is not a cube, so it stays. The y squared is not a cube, so it stays. All right, so the best you can do is write the rest as a third cube. Okay, so either you can get out of the radical sign as a third cube, or you have to stay. Well, sorry, 2 squared and y squared, you have to stay. You're not a cube. Y squared is 4, and, 2 squared is 4, and y squared is y squared. So gross, right? That's pretty nasty. You're not going to see a ton of them. Problems like that, they're just not really fun to work with. They're just kind of ick. I mean, doing some of this radical stuff is already kind of goofy, but then to have to break down a number and then break down the number inside the breakdown, it's like, come on, man, give me a break. So anyway, we'll try to avoid those as much as possible. So we're not going to do a ton of those. All right, here we go. Let's go ahead and move on to the extra practice. Here we go. 10, there's nothing sticking to the 10, so it stays 10. 4, kick it out. So it's going to be a 4 with a power of 3 on the inside. So there you go. 4th root, 8 to the 3rd power on the inside. Okay, now the whole thing gets a 3/4. Oh boy, so this is going to involve a rewrite here. Again, usually it's best practice to follow the frying pan rules first and then see what happens. Okay, so we're going to have a 10 to a 3/4 times a b to the 3/4. Okay. Oh boy, 10, can you break it down into fourths? I don't think so. B, can you break it down into fourths? Not really, it's got to stay inside the radical. So here's what you're going to do, friends. If neither of them can be broken down into fourths, then they have to be rewritten as a root of 4. All right, so basically they just go right back in. All right, so this is going to be 10 to the 3rd power, b to the 3rd power, okay? So none of that can be broken down like up here. See how the 5 could break down to 32, so it becomes a regular number. Sorry, 10, you're not a fourth. You're not a power of 4, so you're not going to get broken down, so that means you got to stay inside the radical. Only the proper numbers can get out of the radical sign, so we'll talk more about that the more examples we do. And then from here, the only thing you could really simplify is 10 to the 3rd power, so this one gets kind of, it's not as bad as this example. It's not as bad as this one, but it's still kind of like, ugh. 10 to the 3rd power is 1,000. And then b to the 3 stays b to the 3. So ew, but also not terrible. There's another way to do this one where you could kick the 4 out right away. So you could kick it out as a 4th root of 10b to the 3rd power. That's another way to do it. You could kick the whole 4 out before you even frying pan it. And then same thing would apply. The 3 powers the 10 and it powers the b, so you get right to this step. So you get to the same move regardless. All right, the last 2 here, we have 16 with no exponent, so it stays a regular 16. Leave it alone. Kick the 2 out. So you could write it as 2 with a radical sign and 3 on the inside. Now again, remember, 2, when you kick the 2 out, you could write it there, but you don't really have to. So it's actually best practice to, if you kick out a 2, you don't really have to write it. It's kind of invisible. Oops, it's a C, bro. There we go. So again, I don't have, do I have it up here? I thought I had it up here, but yeah, remember, so any plain radical is the same thing as a 2. Okay, those are the same move. That 2, just we don't always write it. Okay. Last one here. So we follow the frying pan rules. Let's see here. Stick to you, rewrite. 16 to the 3 halves, D to the 3 halves, okay? So over here, 10 to the 3/4, nothing you can do about it. It's not a fourth power, but 16 is a second power. So you could break that down into 8 times 8. And then if you pick 3 of them, 16 to the 3 halves turns into 64. Okay, and then D to the 3 halves, well, let's write a radical sign. Kick the 2 out. So again, you could write the 2 there, but you don't have to. D3. There you go. So there's that guy, there's that guy. So just a little bit of difference there, friends. When you have brackets around the group or not around the group, things change just a little bit. All right. So that is converting to radical form. Basically, remember the whole idea. Take it nice and slow. The number on the bottom, the fraction, exponent, the denominator. Kick that number out. Rewrite it as a root. And see what you can simplify. Take it one step at a time.